Hello everyone, video 4 of module 4. In this video we talk about applying load on different types of elements. So let's start applying load on points. So if I, for example, select this point and I want to apply load on these, I can come here and use this assign joint force or ground displacement, or I can come to assign and come to joint load, and I have the same options here, forces and displacements. So forces is pretty normal and standard. You need to select your load pattern at first, for example superimpose dead load, and you need to address if you want to apply in a global direction or local direction. When you say local, you will use the local axis of the joint. So if I press here, you can see it's coming to 1, 2, 3, which are addressing local axis of 1, 2, and 3 for the joint. If you want to see that local axis, you can come here and click on joint local axis and apply, and then you can see here what are the local axes. So if I zoom in here, you can see axis 1, axis 2, and axis 3. They are not necessarily aligned with global axis, so you need to choose how you want to apply loads. Generally, global axis is more convenient, but if there is any specific angle that you want to apply load, then you need to go for local axis. So you have force in global X and Y and Z direction, and also moment. So you can apply all of them at the same time, or if for any reason you forget, you can add to the existing load later on. So you have few options here. For example, if you apply load here, say global X 10 kilonewton, and then global Y 5 kilonewton, global Z 20 kilonewton, and you may have even moment, for example, say moment X 10 kilonewton meter, and apply here, you can see all of them here. So I will remove this extrude just to make it more clear for you. Yes, you can see here the loads. I'm just zooming in a little bit more. So here in this point you can see these 210 coming. So one of them is the moment in global axis, the other one is the force. So when you have a moment, the arrow is a bit different. So if I come to load, I can see them here, but just to make it clear, so if I remove this 10, make it 0, and apply it here, you can see the arrow of the moment is different in terms of shape with the arrow of the force, and this arrow basically showing the right hand rules. So this is grid 1 and moment is in the positive direction, so it's showing like this. If I put here -10 and apply on these, you see the arrows change now because it's -10 according to right hand rules. It's showing the other way. Actually this arrow is addressing your thumb, and based on right hand rules. So if you keep your thumb aligned with this arrow, you can see the right hand rules works, and it show where the moment direction is exactly. And the same for loads. If I change, for example, Z to -20, and then here I replace it, you can see it's coming back. The other option you have is add to existing. For example, I may change all of them to 0, and then I'm coming and add something to existing one. For example, moment in global Y, I put 30 here, and when I use add and apply, this moment is added here. If you right click on the joint and come to the loads, you can see the load, but if you added something later, it's coming as a separate a group of loads. How many, doesn't matter how many they are. They will be added together at the end of the day, but they will be shown separately. To make it more clear, if I, for example, in global Z, currently we have -20. If I add +30 and put this one 0 and then add to the existing, what you see is the resultant force of in Z direction, which is 10 totally, -20 +30. But if I right click here and come to loads, I will see them separately. So I have -20 here in another group of load, which is applied later. You can see this is +30. That's how it's shown. So you can see the history of changes in loads, or if you want to apply load separately for any reason, you can check it here by right clicking on the element, could be joint or frame or shell, doesn't matter. And the other option you have is simply just deleting everything if you made any mistake, if you don't want them, and when they apply, all of them will go. And when you want to apply other loads for other load cases, you definitely need to come here and change them. So be very mindful when you are applying load, so don't mix them up. So this is for joint. The other option we have for joint is displacement. If I back to my original view, for example, one of the pies, for any reason, we have some extra settlements. So just remove this local axis to make it more clear. So if I zoom in and come here and I want to apply displacement here, I can come to displacement or go to the assign menu here and joint loads and displacement. And so the load combination, that load pattern, actually displacement is correct. Then I need to put based on meter. Just be very mindful about the numbers here. So for example, you may have 20 millimeter extra displacement here and you want to apply it to the building. So you need to come here, and this is global Z direction. So if it's a settlement, that means in the negative Z direction. So you need to put -002. So this is 20 millimeter settlement here on this pile. This settlement is in addition to the settlement you see in the whole model due to the loads. So that would be added, and you need to use this load case in any relevant load combination you want to see the effect of this settlement. So these two options are for joint load. So I will remove this because I don't want to have it. I can put it 0 here and replace, or I can delete existing. So both would do the same. So I close these and I will back to my original view. Now let's see what options we have for applying load on frames. So I'm zooming again here a little bit, and I come here, for example, on this beam. I can select this beam and say for example, what type of load I want to add. For frame, again, we have few options. One is assigned point load to frame. So let's try this one. I will click here. Typical procedure we have for loading. So we need to choose what type of load pattern we want to use. So say live load, and here which option we have is that add, replace, or delete. So I choose replace here. I have few options here for load. One is the load direction, is that X, Y, or Z, or gravity. The difference between Z and gravity is when you apply gravity, you just need to put the positive numbers here, and that would be downward automatically because gravity is in Z minus direction. If you put Z, then you need to dictate the direction of the load. And is that either force or moments? You have these two options as well. So let's try gravity force. I have two options here to clarify the distance from the I end of the element. So I need to figure out first of all which end is I end. So I'm coming here for local axis and I apply these. Now I can see this is axis 1, that means this is I and this is J. So I just untick this one for clarity. So from I end I'm addressing. If I choose absolute distance, I need to give exact number based on meter, which is the unit is here. So I am allowed to apply up to 4 forces at the same time. If I need more, then I need to add it later to this 4. So say, for example, absolute distance 1.2 and the gravity load is 10 kilonewton. And when I apply here, you can see it's coming from 1 meter from the I end. If I use relative distance and then I come here and say, for example, 1 again, that is relative distance. That is 1 means 100% of the whole length. So literally the load will be applied here. So if I put add and add it to this one and select this element and apply, you see the load going to the 1 of the ratio. So 1 is the total length of the element. So if I choose, for example, 0.25 and apply, this time Z direction, say 20, and again add it. So by selecting this and apply, you can see that 20 coming in a 25% of this length from IN, and this is upward because this is Z direction, so I didn't put any negative sign here. And the same for moment. I can come for moment and say, okay, I need a moment at 75% of the element. This is in X direction, and in X direction again based on right hand rule. So if I put positive 10 kilonewton meter and add it here, you can see the arrow is along X axis. So I select this one and apply, and you can see the moment coming here, and this is in positive X axis. So this is how the system works. You can use local, and the local is, when you put local, that means it's not exactly on this. If I use the same here now and put it, for example, here, just to compare with X, and add it up to this, you can see this is not aligned with the element, but this is aligned with the element. That means this is aligned with axis 1, but this is aligned with axis X. So so those are global coordination. So you need to ensure what type of load you are applying. For moments, you need to go for local axis always. For gravity, you can use the projection and use gravity or negative Z in this direction. So those are the options for applying load. What you need to consider is, if you applying moment, you can just see the moment. If you applying force, then you can just see the forces, but all of them are here. So if I right click on this element and coming here, you can see all loads are shown here. After running the model, we start showing how we can see the result, and then I can actually explain you in more detail. But just to make it clear here, if I come to display and come to showed element load assign and coming to frame, here I can choose any kind of load pattern and say, okay, what I want to see. So this is a span loading forces, a span loading moments. You can see they are in different categories. So if I press apply here now, I can see the forces I applied before. If I come here and say current displacement, so put apply, I can see the moment. You can see this moment was aligned the local axis. Now it's actually different, and I can see the components of the moment in X and Z direction. But if I change this one to frame local axis and apply, I can see this one correct, but this one is changed because that was along X direction. Now I can see it along local axis 1 and local axis 2. What are the components? If I come to global, again this one is changed and you can see this is correct. So we will go through this detail later on. I just want to show you that's what's happening. You must be very mindful when you're applying load. One thing is very important, that forces and moments are separated, but if you use replace at any stage for this load case, whatever load you assign for this frame will be replaced by that specific load, including forces and moment. So you saw that currently we have all forces and moment here, but if I come here and for example go to force and say I just want to see these, and I replace it on these and I press apply, if I right click here now and go to loads, this is the only force you can see. So be very mindful, because you cannot see all loads at the same time. When you are using replace, that means you are replacing all moments and forces for this specific load pattern. So this is one option that we have. The other option we have for beam is using distributed load. So this is the option, distributed load, or I can come to assign and go to frame loads and come to distributed loads. Again, I have the same options as you see. I can put and use any kind of load pattern, say superimpose that load. There are two options here. One is the uniform loads. That means the number you put here, that will be applied all along the beam. It's up to you. Is that gravity or along axis X, Y, or Z, or X, Y, or Z projected, and also gravity projected because this is in angle. So if I choose gravity and I put here 10 and apply, you can see the gravity is normal to the axis 1. But if I choose this one and put here gravity projected and apply, then it's coming in this way. So this is 10, but 10 is in Z direction. So the projected on along this would be 993 based on the angle. So that will be multiplied by the cosinus theta here that we have. The same for X and Y and Z. You guys can try it and see the differences, and we can discuss in our workshop. You have the same option for moment here. So distributed moment, if you have such a distributed moment, so you can say okay, in the local axis, generally moment is along the elements, you need to use local axis. But if you have in a specific case that the moment you have in the result you receive from another consultant is in X and Y and Z direction exactly, you can put it in X and Y and Z. So I'm coming here and say okay, uniform moment load I have, say 2 kilonewton meter per meter, and if I select this one and add it and apply it, you can see this moment all along the building. And the same principle you have here for the relative distance. Sometimes you don't have that distributed load all the way, so you can give some numbers here. For example, you may start with 0 of the relative distance, but at point 25 you may come for say 10 kilonewton. Let's change it to force, but makes more sense. And I'm coming to global, I'm choosing gravity. So I'm replacing just for clarity to avoid of any confusion. So I don't have this one. Then I'm coming here, so 0, start from 0. Then when I'm coming to 25, I'm 10. Up to 75, I am 10. And when I'm coming to the end, it's 0. So it gives me a trapezoidal shape of load distribution here. If I select this one and apply, you can see what's happening here. So you can play with the shape of the load. You just may have just two of them. So you have 0 at the beginning, and then 1 for example at the end, that would be 20. Yep. So If you put 0, 0, 0 here, all of them, then it doesn't give you this option. So just be mindful. That means it literally starts from 0.75. So if I press here and apply, you can see just here because you dictated 0 here. What you need to do, you need to put all of them 0, then select this one and then apply. Then you can see the correct one. So it doesn't have to be at the end. It can simply come to here and you have this and the rest is just 0, 0, 0. So that's how you can play with this, and the same for absolute. And this is basically for distributed load. And the other option we have is thermal load. So thermal load, when the buildings generally, especially if elements are exposed to weather, you may have a minimum and maximum temperature. If it's inside the building, generally the temperature is controlled, so you don't have too much thermal forces. But if they are externals or very close to the cladding, so they can absorb heat and cold weather, then you need to consider thermal load. Depends on the importance of the structure. It's back to the design criteria dictated by client to you. If you want to go for worst case scenario, you can, but it may not be cost effective. So you need to see the ambient temperature at that time of construction, and then see when the structure is constructed and restrained, then what would be the difference in a hottest and coldest comparing to the time of construction. So if the, for example, time of construction is 10 degrees and the hottest one is 30 degrees and the coldest one is, for example, 0, then you have a minus 10 one side and plus 20 another side. So you may apply both of them. What options we have here, if I come to assign frame temperature load, I can choose the relevant load pattern, and then I need to dictate what gradient I have. Do I have any gradient? For example, generally when you set temperature, this is along I have axis 1, but if you set gradient 2, 2 or 3, 3, that means you choosing this gradient along axis 2, 2 and 3, 3. For rod element or frame element, it's not serious. Mainly we're checking along the element, so we keep it temperature. And here you can mention by element or by joint pattern. I will explain joint pattern later on when I'm talking about surface pressure, but the joint pattern, long story short, is giving you the pattern of increasing the temperature. So you may give some numbers and values here and say, for example, this is the center of the heat, so here is hotter, here is a bit cooler. So you don't have a fixed thermal expansion or thermal load for all along the building. If you choose this one by element, you just give a fixed number, say 20 degrees. So that's all. When you apply, that means the whole element is subject to 20 degrees actually different temperature. But if you have joint pattern, you can play with the temperature, and you have a basic temperature that would be multiplied by the numbers and patterns you will introduce. I will discuss about that in surface pressure. And again, you have these options: add or replace or delete. So if I apply this one here, you can see it's showing me 20 to 20 degrees. That means all along this element I have one fixed different temperature and temperature load. So those are for options for frame. If I select this one just to show you and come to assign, come to frame loads, you can see there are more options here for frame load, but those are for advanced courses. So temperature, distributed and point load is explained. Gravity load is a kind of factored self-weight load that you can apply to any direction as a force on your elements. For example, you want to use 20% of the self-weight of the element in X or Y or Z direction as a kind of force. Could be earthquake force, could be any kind of force that you have in your design criteria. You can come here and apply the multiplier factor to the self-weight. So the number you see here is not the actual value, it's just a percentage of the self-weight of that specific member you have. and could be positive or negative, could be more than one, depends on the value of the load you want to apply, and could be less than one as a percentage. This is what you can use. I personally haven't used it too much, but it's available, and you can apply it if you want. The last thing I would like to share with you about frame element loading is wall EQ. If you remember, I defined a load pattern named wall EQ, but I didn't use it in load combinations. So I created a load case named dead, and I added all dead loads I would like to use them in my load combination. So if I come here, you see wall EQ is not here. It's just self fade, superimpose dead load, and wall with factor 1. But I added this wall EQ into mass source. So the wall EQ is here. So what is that for? When you want to calculate earthquake load, the logic of calculation is whatever is up to half of the height of a story above floor and half of the height of a story below floor should be the mass for that floor, and it should be lumped at the center of mass. But SAP doesn't understand this. What SAP does is SAP calculating all loads above floor up to the next floor plus this floor and lump it to the mass. So when you have all typical walls coming, they are almost similar if you have the same wall material. So you have full height of the wall for each floor above the floor. But when you reach to the top floor, you don't have the mass of the half of the height of the wall below. So how we can make it correct? In this model, the top level is light, so I assume I have a cladding here, very light. I just ignore the weight of this wall to simplify my explanations. I assume there is no wall load here. I need to have the mass equal to half of the height of wall below to be added to the mass of this floor. That's why I have this wall EQ. This wall EQ wouldn't be participated into load combinations, but it's in the mass source. So I'm coming here, I assume, okay, I have a 200 millimeter brick wall below, so 200 millimeter brick wall is something about 3.8 kilonewton per meter height, and times 1.5, which is half of the height, is around 5.7 kilonewton per meter. So actually this gravity load is not the correct load type we want to assign, so I need to back to assign. I can, for example, select this element and come here to assign frame distributed load, and then here I can use wall EQ, and in uniform load I can put as a gravity 5.7 kilonewton per meter and apply. So this load, as I explained, is not participating in your analysis for gravity load. It's just participating as a part of mass source in earthquake calculations. So this is generally what I wanted to share about applying load on frame and joints for this course. Now it's time to show you how to apply loads on area elements.